Hey everybody, welcome back once again to Welch's Math class, and we are moving on in our conversation about geometry. We are actually up in section 8.7 in your course compass material, talking about volume. Let's go ahead and get started. So volume is what we would know as the space inside a three-dimensional figure. Okay, so you remember that when we talked about lines and we can measure their length, that was one dimension. Then we talked about plane figures like squares, circles, rectangles, trapezoids, those kinds of things. Those were two dimension. They had length and width, and so we had area for those things. And now we're talking about volume, and with volume we're talking about the space inside a three-dimensional figure. So the three dimensions would not only be length and width, but it would also include depth. Okay? So we're going to be talking about three-dimensional figures. For example, how much water would a swimming pool hold? The swimming pool has depth, it has width, it has length, so it holds a certain amount of water. That's an example of what we're talking about with a three-dimensional figure in volume. The measure, or the unit, is cubed. Okay, so it's whatever the unit is to the third power. So we could be talking about cubic feet, cubic yards, we might be talking about cubic meters. Okay, so it's whatever that unit is to the third power. Remember, area was to the second power, and then just the first power on length. So let's go ahead and look at a couple of figures, and we'll start out with how to find the volume of a rectangular solid. So let me make an attempt here at drawing a rectangular solid. Okay, so we're going to do this, and then we're going to come here, and here, and we're going to come here, and here. Okay, so that was my attempt at a rectangular solid. You might know that as just a box, another way of saying a box. So if I give you some measurements on that rectangular solid, let's say I say its length right here, or actually I might call that its width. Not really sure, it's hard. You could give it a couple of different names depending on what angle you're looking at it from, but let's just say that was 7 inches. Let's say its depth right here, going back, let's say that was 4 inches. And let's give it a height. Let's give it a height of 5 inches. And so what we have, the volume formula for this rectangular solid is its length times its width times its height. And in some cases it would be depth that we might be looking at. So if we call the length 7, we call the width, let's say we call the width 4, we call the height 5. What we'd be looking at, 5 times 4 is 20, 20 times 7 is 140. Now our unit is cubic inches. Okay, so to get the volume of this rectangular solid, of this box, okay, is 140 cubic inches. Okay, so that's a rectangular solid. Got a couple more that we want to take a look at. We won't spend a lot of time on volume, but we do have a couple more to talk about with volume. Let me give myself a little space here. The next volume thing I want to talk about actually is a cylinder. Okay, I want to talk about a cylinder. So with a cylinder, what we have is a circle, but it has height. It might be something like a can. It looks like a can maybe. Sometimes a cylinder can actually be turned on its side and look like a pipe. or a tube. Now, with a cylinder, what we have is we could have one of the circles, and we would have its radius, and then we would have the height of the cylinder come in here at a 90-degree angle. So those are the measures we typically get on the cylinder here, and then its height might be all the way to this end. Okay, so we'll have the radius, or in this case here the radius, and then we'd have the height of the cylinder. Okay, so let's suppose for a second that we want to get the volume of that can. Oh, that cylinder, I mean. Same thing, can, cylinder. Let's suppose it has a radius of, let's make the radius 8 inches. Let's make this height right here 20 inches. Okay? So my formula for the volume of that cylinder, volume of a cylinder, equals pi times the radius squared times the height of the cylinder. Now, because it's got the circular information in it, we're certainly going to use 3.14 for pi. So the volume is going to be approximately 3.14. Now my radius is going to be 8, so it's going to be 8 squared, 8 to the second power, and its height is going to be 20. Now all my units here are inches, and I know in the end I'm going to have a unit of cubic inches. So what I'm going to do then is work this out, and you guessed it, I cheated. I brought my handy dandy calculator. So let me fire this baby up, and I'm going to put in 3.14, okay, and then I'm going to multiply that. I'm going to go ahead and work out 8 squared in my head. I think that's 64. Okay, so I'm going to go times 64 times 20 equals, so I'm getting 4,019.2. 4,019.2, and that's going to be cubic inches. All right, so the volume of that cylinder, 4,019.2 cubic inches. Now notice the wavy equal sign that I put here. That's for that means approximately, because we've rounded off pi to 3.14. Okay, so we've got this example now to find the volume of a cylinder. Cool. Let's move on, and let's talk next about the volume of a cone. Let's talk about the volume of a cone. Oh, I better put this calculator away. There we go. A little pocket calculator, nothing like it. Very helpful sometimes. Of course, you can't use those on your test, remember? Only the on-screen calculator. But that's okay. You'll be fine, because you know how to work that thing. What was I doing? Oh, I was doing the volume of a cone. Okay, so this time we're going to draw ourselves a cone. A cone looks like a cone. Looks like an upside-down ice cream cone or a cone head. Well, a cone, we'll notice, has a circle at its base right here, and it'll have a radius. A cone will also have a height. It's a lot like a cylinder. In fact, the formula for the volume of a cone is very similar to the formula for the volume of a cylinder. Our volume is going to be equal to pi times, and let me back that up a little bit. It's going to equal to pi times the radius squared times the height. Now remember, that is a formula for the volume of a cylinder. So what we're going to do, though, is we're going to take this cone, and we're going to realize there was part of a cylinder here, there was part of a cylinder here, so what we end up with is 1/3 of a cylinder left. So we're going to take this, information for the cylinder, and then we're going to simply divide it by 3. Divide it by 3. Let's do this example out so you can see how this is going to work out for us. So let's say the radius here this time is, let's make the radius 10 feet. Let's make our height 25 feet. Okay, so we've got a 10-foot radius, we've got a 25-foot height. We're going to plug into our formula. So volume of this cone is going to, be equal approximately 3.14 times the radius squared. Okay, so that's going to be 100. 10 times 10 is 100 times the height of 25. Now, once we've finished all that math work, what we're going to do is take that bit right there and divide it by 3. So we're going to put this right up over a 3. To do my math now, though, what I'm going to do first is simply go to my handy-dandy calculator. I'm going to put in 3.14 times 100 times 25, and now I'm going to go equals. So at that point I've got 7850, and then I'm going to divide that top part by 3 equals. Okay, so I'm getting 2616.6 repeated. So volume approximately 2616.6 repeated. How often would that line over the 6? Forever and ever and ever. Let's say we want to round that to the nearest tenth, one decimal place here. We'll go 1 past it. Let's put another 6 in this to show that. Let's round that. So my rounding is going to be 2616.7. My unit was feet, so cubic feet. Cubic feet. There we go. So now there's the volume of a cone. Got one more figure to go. We're gonna knock this baby out. Have you some good examples for this section. So far we've got a good definition of volume. We've got a rectangular solid. We've got a cylinder. We've got a cone. Let's talk about this time the volume of a sphere. S-P-H-E-R-E. A sphere. So a sphere is simply like a ball. A sphere is simply like a ball. What the measurement we want to look for here that they should give us would be the radius of the sphere. Okay, so let's say the radius of this sphere is let's make it 12 yards. Okay, 12 yards. Now my formula is going to be volume equals 4/3 times pi times the radius, this time cubed, the cubed radius, third power radius coming at you right here. The other thing that messes with people a little bit right here is this 4/3 business. I want to show you how to handle that mathematically. First, we're gonna plug in our information here to get our volume of this particular sphere. So volume is approximately, now I'm going to adjust this 4/3 a little bit. I'm going to adjust it a little bit. I'm going to go 4 times 3.14, okay? 4 times 3.14 times 12 cubed. Then I'm going to take all of that answer, and divide it by 3. Divide it by 3. So that's the way I can handle this 4/3. I can multiply the 4, the numerator, through the formula, and once I get that answer, divide by 3. The simplest way I know of to actually handle working out our math. So let's work out our math. Clear off that last one we did. We're going to do 4 times 3.14 times 12 times 12 times 12. Okay, so the top piece of it is, all I can tell you is it's a lot. Sorry I ain't more helpful than that. It's Okay, I'm going to give it a shot here. 21,703 and 68 hundredths. Anyway, it's a lot, right? Now I'm going to take that. That was this times the 12 cubed. I'm going to take this answer and I'm going to simply divide it by 3 equals. Okay, so I'm coming up with 7234.56. 7234.56. And it came out even to the hundredth. Now my unit is yards, so it's cubic yards. Alrighty guys, those are the examples that you'll need to work through the material in, I guess it was 8.7, geometry volume. I'll see you again next time. Jump on that homework, get some practice in, and I'll see you next time. And what are we talking about next time? I'm trying to remember. What is it? Oh, I know. Pythagorean theorem. Aren't you excited? I'll see you then.